Hello! In this video, we will explore how to set up analog input and output for the S300. First, analog voltage and current inputs through the AC drive control terminal can be used for various commands such as setting the operating frequency or torque command, and can also be utilized as feedback for PID control. However, depending on the load system, the minimum and maximum values for commands or feedback may vary. For example, if 0 volts input typically results in a stop at 0 Hz, and 10 volt input results in the operation at maximum frequency, there may be cases where you want the system to stop, even at 2 volt input, or you want it to operate at maximum frequency even with only 8 volts input. In such cases, you must set the frequency settings for the analog input. The same applies to analog output. Through multifunctional analog output terminals like A01 and A02, you can convert inverter operation information such as output frequency or output current into voltage or current for output. Here too, you can adjust the actual output voltage or current according to the output values. Next, we will look at how to set the analog input and output ranges. First, let's start with the wiring method for setting the target frequency with an analog 0 to 10 volt input. The S300 allows you to select and use AI1, AI2, AI3 as either voltage or current through a switch located on the control board. The factory default settings are that AI1, AI2, and AR3 are all set to voltage, so if you wish to select current, change the switch setting. The terminals related to analog input include VR+, VR-, AI1, AI2, AI3, and the 5G terminal. The VR+ terminal is for 0 to 10 volt output. The VR- terminal is for 0 to minus 10 volt output. And AI1 to AI3 are terminals for analog voltage or current input, with 5G being a common terminal for analog input and output. When inputting the output voltage of an external device, you only need to wire it to AI1 and the 5G terminal. If using the inverter's internal power supply, you should wire a 1 to 10K ohm volume resistor to VR+, AI1, and 5G. Now, let's look at how to set the parameters. Analog input-related parameters can be set in the AIN group. First, you set the type of analog input you are receiving. Parameters 1, 16, and 31 in the AIN group do not use negative voltage, so set them to unipolar. If you want to use from minus 10 volts to 10 volts, set it to bipolar. If you want to use current, after selecting current with the switch, set it to current in parameter 2. Parameters 4, 19, and 34 in the AIN group allow you to set the filter time constant for the analog input. This is used when there is a lot of noise causing fluctuations in the frequency setting value. Using a filter allows only clean input signals to pass through. The larger you set the filter time constant, the smaller the frequency fluctuation, but it slows down the response time. The setting time, T, is the time it takes for the internal frequency settings of the inverter to reach about 63% when voltage from an external power source is input as a step. Parameters 5 to 8 in the AIN group allow you to set the input range. You can set the minimum input voltage and its corresponding frequency, as well as the maximum input voltage and its corresponding frequency. The frequency corresponding to 100% analog input can be set in parameter 22 of the DRV group. Next, let's start with the wiring method for 0 to 10 volts analog output. The terminals related to analog output are A01, A02, and 5G. A01 and A02 can be configured through a switch on the control board to output either 0 to 10 volts analog voltage or 0 to 20 milliamperes analog current. The factory default settings for these terminals are set to voltage output, so please take this into consideration. Moreover, 5G serves as a common terminal for analog input and output. To output voltage using a voltmeter, wire the A01 and 5G terminals together. Next, we will look at how to set the parameters. Parameters related to analog output can be set in the Out group. Terminals A01 and A02 are multifunction output terminals. Thus, in parameter 1 of the Out group, you can directly select the output option for A01. The output options range from the operating frequency displayed on the screen to a fixed value output. In this video, we will select the operating frequency at setting 0. In Out group 3, you can set the gain value for analog output, and in Out group 4, you can set the bias value for analog output. Both gain and bias are reflected in the output as shown by the formula displayed on the screen. Next, we will explore how to set parameters related to analog input using the S300 smart operator. In this video, we will set it to operate from 2 volts at 0 Hz to 9.5 volts at 60 Hz. First, press the Mode key to enter parameter mode. Use the arrow keys to navigate to AIN group 5 and set the minimum input voltage to 2 volts, and set the corresponding input level at AIN group 6 to 0%. Set the maximum input voltage at AIN group 7 to 9.5 volts, and set the corresponding input level at AIN group 8 to 100%. The frequency corresponding to 100% at AIN group 8 is the frequency set in DRV group 22, so please take note. Next, let's look at how to monitor the current frequency using 10-volt output with the smart operator. In this video, we will set the bias to 20% and the gain to 80%. Use the arrow keys to navigate to Out group 1 and set A01 mode to 0 frequency. Set A01 gain at Out group 3 to 80%. And A02 bias at Out group 4 to 20%. The frequency at 100% input can be set in the DRV22 parameter. This is not always linked to the maximum frequency, so please be sure to check. If you want to operate at 100 Hz when the analog voltage is at its maximum, you also need to change the DRV22 parameter accordingly. If the analog signal includes noise components, set the V1 filter to a higher value. Next, we will proceed with testing under the parameters set earlier. Wire a variable resistor to VR+, AI1, and 5G terminals using internal power, and rotate the variable resistor to check if the target frequency changes. Below 2 volts, the frequency command will be 0 Hz. Above 9.5 volts, the frequency command will be 60 Hz. Next, let's perform an analog output test. With the bias set to 20% and the gain set to 80%, the graph on the screen will be drawn as shown depending on the output frequency. Thank you.